In this video, we will be estimating the area under a curve. Our problem is, use 5 rectangles of equal width to find 2 approximations of the area of the region lying between the graph of f of x equals negative x squared plus 5 and the x-axis between x equals 0 and x equals 2. Now I'm going to try to do this as closely to accurate as possible, and also give you notes as I go. Our first step would be to determine the width of the rectangles. So our boundaries are x equals 0 to x equals 2. So the total width is 2 minus 0. And then we need to divide that into 5 equal rectangles. So the width of each rectangle is 2/5 or 0.4. So then on my graph, I'm going from 0 to 2. My first mark I'm going to show as 0.4. And then the next one is 0.4 more, which would be 0.8. The next one would be 1.2. The next one would be 1.6. And then the next one would be 2. Now my graph for each of those, I need to get a value of this function at each of these numbers. So I need f of 0, f of 0.4, f of 0.8, f of 1.2, f of 1.6, and f of 2. So at x equals 0, my y value is 5. And I'm going to go ahead and plot that as we go. F of 0.4 is 4.84. So about here. F of 0.8 is about 4.36, which is about here. When x is 1.2, we have about 3.56. About here. When x is 1.6, we have 2.44. And when x is 2, we have 1. So our function, the curve, looks like this. And we're estimating the area under the curve. Now the problem wants 2 approximations. So one approximation is going to come from the lower rectangles, for each of those numbers. And the other approximation, and what we'll be doing is finding the area of each of those rectangles and adding them up. And then the other approximation will come from the upper rectangle. Let's find the lower approximation first. Our lower one is going to be, this is our top of our rectangle. So we're actually finding the y value when x is 0.4 for the top of the red rectangle. So f of 0.4 multiplied by the width of the rectangle, which is 0.4. And then our next rectangle has the height of the rectangle is up to here, which is a y value when x is 0.8. So f of 0.8 times the width, which is 0.4 again. For my third rectangle, the height of the rectangle is the y value when x is 1.2. So f of 1.2 times the width of the rectangle, which is 0.4. And then for my fourth rectangle, the height of the rectangle is the y value when x is 1.6. So f of 1.6 times 0.4. And then for this rectangle, the height of the rectangle is the y value when x is 2. So f of 2 times 0.4. Now if we do the math on these, this comes out to be 1.936. This one is 1.744. This one is 1.424. This one is 0.976. This one is 0.4. And the total of all of those areas is 6.48. So that's my lower approximation. My upper approximation, let me put that here. That's going to be the green rectangle. So the first rectangle has a height, the y value when x is 0. So it'll be f of 0 multiplied by the width of the rectangle, which is still 0.4. For my second rectangle, the height is the y value when x is 0.4 times the width of my rectangle. For my third rectangle, the height is the y value when x is 0.8 For my fourth rectangle, The height of the rectangle is the y value when x is 1.2. And for my fifth rectangle, the height of the rectangle is the y value when x is 1.6. Now the values for these, this is 2, this is 1.936, this one is 1.744, 1.424, and 0.976. So my upper approximation, the total of all of these areas, is 8.08. So I can then say that the area under the curve of f of x equals negative x squared plus 5 between x equals 0 and x equal 2 is more than 6.48, but less than 8.08. Now, if we wanted to get an estimate that was more accurate, we could divide our area into more and more rectangles.